Hey everyone, Praveen this side. I hope you guys are doing great. So today we are going to solve the problem count distinct elements in every window, which is an easy level problem, but we are going to learn so many things inside this problem and I'm going to share a trick with you with which you can solve these kind of problems very easily. Okay, so let's see the problem description first. The problem says given an integer array ARR and a number k. Now find the count of distinct elements in every window of size k in the array. So the problem statement is pretty self-explanatory, right? That we have been provided with an integer array and k. Now we need to find the count of distinct elements. We need to find the count of unique elements in every window of size k. Okay, so if you see the examples, it will be much more clear. So from the examples, in example 1, the array given is 1, 2, 3, 3, 4, 2, 3, and the k value is 4. So the output is 3, 4, 4, 3. Now it might be very difficult to understand this output without going through the explanation. So let's consider the first window of size k. Then it will be this much, right? Now from this window, if we try to count the unique elements, it is 1, 2, and 3, right? And the count is 3. So that's why the output is 3. Now, if we shift to the window, now if we consider this window, the elements are 1, 2, 3, 4, right? So we have totally 4 elements. So that's why the second result is 4, right? Similarly, for the third window, it will be 4 and the fourth window, it will be 3. So this is what the explanation says about each window, okay? Now, if we look at the second example too, the array is 411 and the k is 2. So in the first window, we have 1 and 4, right? 1 and 4. So the count is 2. But in the second window, we have both 1 and 1. But we want the uniques, right? So the count will be just 1. Now, in the third example, the array is this and the k value is 3. So if you look at the every k size window, we have only ones, right? So every time the output is 1. Okay. So we have also understood the examples well, right? So now let's see the constraint to get the more clarity on the time complexity and what the variables need to be used in the problem. Okay. So if we see the constraints, we have both k and array size within the range 1 to 10 to power of 5. So if we look at the upper bound, which is 10 to power 5, we can get a clear signal that we can solve this problem within O of n log n, right? We cannot increase the time complexity more than this. And if we say the array of I, where each element is in the size of 10 to power 5, so we can store this in integer. Now, since we have also understood the constraints and got the idea about time complexity, right? So let's take example 1 as reference and we'll try to find few observations from it, which will build our intuition to solve the problem. Now, before jumping into example dry run, there's a quick note here which will greatly help in identifying these kinds of problems. Okay, I personally use this trick to identify whenever we have k in the problem to identify this problem. Whenever k is given in the problem, so whenever we have k value which is given in the problem and the problem is related to window, then we should be thinking about the sliding window and the hash map or the combination of both. Okay, but when k is given in the problem and it is related to find the minimum or maximum, like we need to find the k minimum value from the array, k maximum value, something like this, then we need to think about the priority queue. This priority queue can be both min heap or max heap depending upon the problem, or the ordered set or ordered map. Okay, so scan this image and store it in your brain. Okay, whenever k value is given and it is related to window, then we need to think about this, or whenever it is related to finding minimum or maximum value, we should be using priority queue or ordered map. Now coming to window related problem, it can be used individually or there may be some problem where we will be using the combination of these both, and today's problem is one of them. So let's see how to build intuition for this. So for our brute force approach, we'll be using only hash map. But for our optimized approach, we'll be using the combination of both hash map and sliding window. How it is, let's see. So the array given is this and the k value is 4. That means we need to find unique elements within the window of size k, right? So what does the brute force approach says? Just generate all the possible k windows, right? So the first k window will be this, the second k window will be this, the third k window will be this, and so on, right? So for this we'll be using two nested for loops, right? The first loop will be to track at which position we are, and the second loop will be to traverse from that position till k size. Okay, now, when we get this size of window from those two loops, we can store these individual elements in hash map, right? So if we store it in hash map, we already know hash map stores the unique elements, right? So 1213 will become 123. And what is the size of that hash map? It will be 3. So we can simply input the size of hash map inside our result. So let's see the code to get much more clarity on this. So this is the code in C++, although the logic remains same. Okay, so the function name is count distinct, where we have been given with an array and k. So firstly, we have taken array size and stored it in n. Okay, then we have declared a result variable which will be returning in the last. So as we discussed, we need to use two nested for loops. One loop to track the position we are at, and the second loop to traverse from that ith position till I plus kth position. Okay, now let's suppose our ith pointer is at position 2. Okay, I is at 2. Now j will be running from I till I plus k, right? So I plus k will be 2 plus 4, which is nothing but 6. So j will be running till 6. So if we draw the window for this from 2 to 6, it will be from here till here, right? Where we are getting 5 elements. But here I have wrote the condition from I plus k. Now if we draw the window from position 2 to 6, it will be from here till here, right? So here we are getting 5 size window, right? But we want only 4. So that's why I have written less than I plus k, not less than or equals to. Where here I have written less than or equals to n minus k. Okay. Now what is this n minus k? Because we need to find the k size window, right? So if we are at index 6, can we find the k size window? No. If we are at fifth position, no, only 2 elements. If we are at the fourth position, no, only 3 elements. But if we are at the third position, then only we can find 4 elements, right? So the maximum limit the I can go till index number 3, right? So if we submit n and k values here, so it will be 7 minus 4, which is nothing but 3, right? So that's why we are iterating till n minus k. So inside this for loop, we have created a hash map. And inside this jth loop, we are adding array of j in the hash map and incrementing its count by 1 every time, right? So when we exit from this loop, we'll be having all unique elements present in the hash map, right? So we can directly push the map size inside the result. So when this ith loop gets exhausted, we can simply return our result. This way, we can use hash map and solve this problem in brute force way, right? Because this is a complete intuitive problem, right? That we know we need to consider k size window. For that, we can use two nested for loops, and to store the unique elements, we need to use hash map, right? So this is very intuitive and brute force approach that every beginner will get. Now, if we discuss the time complexity of this problem, what will be the time complexity of this problem? What will be the time complexity of this problem? Here we are using two nested for loops. One loop which will go from 0 to n minus k, which we can approximately say it as n, right? So outer loop will be O of n. And internally we are running a loop from I to I plus k, right? So this loop will be running to k positions, right? So the overall time complexity will be order of n cross k. Now, what will be the space complexity for this approach? Here, we are using a hash map internally, right? And this hash map can store up till k values in the worst case scenario, because we are iterating from ith position to I plus k position, right? So, if every element is unique, we can have just k elements present in our array. That's why the space complexity will be order of k. And we need not be caring about the result space, because the problem itself expects us to return a vector of int. So the only additional data structure we used is hash map. Now if you try to submit this problem will give TLE. Why? Because as I said, the problem can at max go till O of n log n or O of n log n. Both are same, right? O of n log n or O of n log k. But here we have solved this problem in order of n cross k, which will definitely give TLE. Now we need to optimize this problem, and you already know how we can optimize this problem by using the combination of hash set with sliding window. So what is sliding window? First of all, suppose we have a k size window. Here k size is 4, right? So we have considered this size of window. Now we need to slide this window. This is acting as a window, right? We need to slide this window by one position. So if we slide this window by one position, how it will look? It will be from 1 till 4, right? 1 till 4. So this is the sliding window approach. It has a meaning in its name itself, like we are sliding the window, right? Now why to use sliding window? That is the second question, right? So if we take the first window, it is well and good, right? But if we take the second window, which starts from index 1 to index 4, as you can see, there are three overlapping elements, right? There are three overlapping elements, 2, 3 and 4, right? The only element which got added in this window is 4, and the element subtracted is 1, right? Remaining this 2, 1, 3 are same, right? The same way, when we are at this window, right, and we need to shift the window, we'll be shifting this window to this position, right? So we got the addition of this, and this one got eliminated from here, right? So we have created a new window. So we are reusing the elements, right? We are deleting the first element and adding the last element. Remaining the middle elements are being reused. So that is the intuition behind using sliding window. And when we use sliding window, to maintain the frequency, we'll be using the hash map, right? So it is a combination of sliding window plus hash map. Okay, so let's see the approach of this. So let's write on this example with sliding window approach. So here I have created a map where the number is the key and the frequency is the value, right? So again we are with the same array and the key value is 4. But here I have taken a hash map where key is the number and value is the frequency, right? So let's consider the first window. So in the first window, we don't have any addition or deletion, right? Because it is the first window. So what we can do? So we are running a first loop from ith position till kth position, right? So we are running a first loop. So we need to add these elements in our hash map. So if we add these elements, it will be like we are adding 1 with the frequency 1, 2 with the frequency 1. Again we encountered 1, so the frequency will be 2, and 3 with frequency 1, right? We have completed our window and we have set up our configuration, right? Now we need to slide the window. So if we slide the window will be this much, right? Now before that we need to also return our result, right? So result will be, initially when the window was from 1 to 3, we had the map size as 3, right? So in result we'll be having 3. Okay, now we have shifted our window. So when we shift our window, what we need to add, what we need to delete, this element got added and this element needs to be removed, right? So when we are at the ith pointer, right? So this is the ith pointer. What we need to do, we need to add this entry in the hash map, right? So we will be adding 4 with frequency 1, right? Now we need to delete this element, right? So to delete this element, what we can do, if our ith pointer is here, how can we get it here? Basically, if we do I minus k, okay, if we do I minus k, it will be 4 minus 4, which is nothing but 0, right? So we are able to access the deleting element index, right? How we did it? Basically by using I minus k, right? I'll write it here, I minus k for deleting. And for adding, what we did, for adding, we added the ith element. Okay, so for deleting we are using I minus k to delete the last element, and for adding we are adding the ith element, right? Basically this one. Now how can we delete this ith element? This ith element information is stored in hash map, right? So we need to decrement its frequency. Okay, as this one have been removed from this, we need to decrement its frequency. So this frequency from 2 will be coming back to 1. Okay, the frequency will be 1. If we cross check the frequency array with our window array, we have 2 with 1, okay, 1 with 1, okay, 3 with 1, okay, and 4 with 1. Simple, right? Now what is the size of the hash map? The size of the hash map is 4. Okay, so we'll be storing 4 for the second window. So we need to shift our window once again, right? So we're shifting our window till this much. Now again we need to add the ith pointer element and delete the I minus kth pointer element, right? So this pointer will be not here, it will be here. Okay, so the ith pointer element is 2. Okay, so we'll be adding 2. First we'll check whether we have 2. Yeah, we have 2. So we'll increment its frequency, right? See, so the frequency will be from 1 to 2. Okay, now we need to delete the I minus kth element, right? So I value is 5 and k value is 4. So 5 minus 4 will be 1, right? So we need to delete this element. Now to delete this element, what we need to do? We need to decrement its element frequency by 1. Okay, so for 2 the frequency will be decremented by 1. So again it will become 1. Okay, now what is the hash map size? The hash map size is 4. So the output will be 4 again for this window. And finally, we'll shift our window one position ahead. So our window will be this much. And our light pointer will also be shifting from here to here. Okay. So in this window, we are adding the element 3, right? So we'll be incrementing its frequency by 1. So 3 will become 2. And we need to delete I minus k. So here I is 6. So 6 minus 4 will be 2, right? So we need to delete the element at index 2, which is nothing but 1. So we'll decrement the 1 frequency from 1 to 0. Now when the frequency becomes 0, that means this element doesn't exist in that window. So we can simply remove this window. From the hash map, we can simply erase this entry, right? We are erasing this entry. So the one entry has been removed. Now what is the hash map size? The hash map size is 3, right? So we'll output 3 for this entry. So we'll output 3 for this window. Okay. So even if we check manually for this window, how many unique elements we have? 1, 2, and 3, right? Because this 3 is already repeating. So we have only 3 elements, and that's what we have outputted in our result. So this way, with the combination of hash map with sliding window, we can easily solve this problem, right? Now since we run the example 2, right? Let's see the code of it. So here's the code in C++ with the same function, okay, where we have taken the array size. So here we have declared our hash map outside the loop, right? Initially we used to declare hash map inside the loop, but we have declared the hash map outside the loop and the result vector. So firstly, we are processing for the first window. How we have processed the, in the same way, we are running a loop from 0 till k to process the first window, and we are simply adding array of I inside the hash map. Okay, so after executing this loop, we are simply inserting the map size inside the result. Okay, the second window will be starting from position k, right? So when we started this window, so our second loop is started from k till n. Now why we have started our ith pointer from k? Because initially we have processed this much window. Okay, so when we are jumping to this window, when we are sliding our window, we are basically adding the fourth index element, right? Then fifth index element, then sixth index element. So the loop which is starting from 4, right? And the value of k is also 4. That's why we are starting our loop from k. And every time what are we doing? So what are we doing inside this loop? To add an element, we use the ith pointer, right? So we are incrementing array of I with +1. And for deleting, what do we delete? I minus k, right? So we are deleting array of I minus k by 1. After decrementing I minus 1 element, we are basically checking here if array of I minus k is equals to 0. Now what does this signify? That it is out of the window, right? So when it is out of the window, we can simply erase from the map array of I minus k. So after this computation, we can simply push the map size inside the result, right? So this for loop will be starting from second window, third window, so on till nth window. And finally, we'll return our result. So this way, by using sliding window approach, we have successfully solved this problem. What will be the time complexity for this approach? Initially, we are running a loop of size k. So this will be O of k, right? And here we are running a loop from k till n, which in the worst case we can say as O of n, right? Approximately we can say it as O of n. So together, this loop will be order of n plus k. Okay, let me write it with the normal pen. So time complexity will be order of n plus k, right? And what will be the space complexity here? We are using a hash map, right? And in this hash map, we every time add element and delete element, which will maintain the balance of only k elements, right? So the space complexity will be order of k. Even when we are performing dry run on this array, the size of the hash map was constant, right? It was going at max till 4 size, right? So that's why the space complexity is O of k. This was the video, guys. Now again, before ending this video, I want you guys to map this in your mind. Okay, this approach is very helpful. When I saw this problem, the first thing I got in my mind is the same thing, like the k value is given. So is it related to window? Yeah, window. Then I directly got the hint that I need to use sliding window or hash map, right? But if it was related to minimum or maximum, then I would have used these things. So I hope you guys like this video. If you guys really did, then please like, share and subscribe to my channel. It will really motivate and support me to make more videos like this. If you guys are new to the channel, please consider subscribing. It will really motivate me. If you have any queries at any step, you can please comment it down. I'll try to respond to it as quickly as possible. And if you have any feedback for my teaching, please comment it down too so that I can improve on that. So see you guys on tomorrow's video solving any other kind of problem. Till then, stay safe, stay happy and peace.